All right, mathematicians, so this lesson is on operations with rational numbers. So rational numbers are a number that can be represented by a fraction of two integers. So like 3/4 or 4/6 or negative 2/3. Irrational numbers are a different set of numbers. Those are like pi and the square root of 2, numbers that don't have an exact decimal that we can put it to. Like with pi, we can get really close, 3.14159. Maybe you can go longer, but there's no exact fraction that works for pi, so we call it irrational. But there are operations we can do with both sets of numbers. When you get into 8th grade math, you'll do some work with irrational numbers. For 7th grade, we're going to do operations with rational numbers. So this is with working with fractions. So you may have already seen this. This might be review for you, but we're going to go over it anyway, because fractions seem to give students the most difficult problems. And I want to show you perhaps a simpler way, or just something in your book that you can refer to. So I'm actually going to take it all the way back to talking about the greatest common factors and the least common multiples. And then we'll go on to adding and subtracting fractions, and then multiplying and dividing. For this first part here, this first video, you should have in this packet these 3 pieces of paper. Okay, this one is an on your own, that's going to go on the left side, and then these both kind of go together. So what you're going to do is you're going to first cut this out. Okay, cut that out, and then on that line as well, and we're going to fold it, and it's actually going to end up being glued on here. And this paper you're going to cut out. Okay, and then that's going to be put onto your book. So really the notes are going to be on these pieces of paper, and then it's going to be glued into your book. So you can go ahead and start cutting these out now, and pause the video. All right, now that you have all of those cut out and this piece cut out here, what you're going to do is take this and fold it in half. As perfect as you can. Okay, and you're gonna unfold that and cut it just between the middle so we can open these flaps up, not all the way, and we can put some glue on the back here. So that this gets glued right here. Right, and now we can fold these up, and we're going to write in there, and we're going to talk about least common multiple versus greatest common factor. Okay, so we're going to start with something just a little bit different. We're going to start with an I can statement here. So I can find the least common multiple and greatest common factor given two numbers. So find the least common multiple and greatest common factor between two numbers. Okay, and let's talk about each because they are very different and a lot of students get them confused. Okay, the least common multiple. So that is the smallest, and let's do that in a different color. Why don't we do that one in, I'll do that one in green. This is the smallest, I'm gonna underline smallest, okay, common multiple that is divisible by both numbers. Okay, so that is the least common multiple. And I'll choose purple to do the greatest common factor. So the greatest common factor is the greatest, right, or largest common factor that is divisible by both numbers. And so you might be asking yourself, well, what is the point? Why does it really matter? It's good to know the difference because, the GCF is looking at the common factor, while the LCM is looking at the common multiples. And when you do things like factoring in 8th grade, and we're going to get a little bit into that in Unit 2, we're actually looking for the GCF. When we do things like add fractions, we're looking at the LCM. Okay, so those are the two differences, and it's really easy to confuse them because even look at their definitions, right? Everything's kind of the same except for smallest and greatest. So it can be kind of confusing. So the difference between LCM and GCF is that GCF is looking at common factors, factors are numbers you multiply to get to a number. So if we're looking at the number 6, a common factor of 6 would be like 3 and 2 because 3 times 2 are both 6. So GCF is looking at common factors while the LCM is looking at common multiples. Okay, and we'll do a little bit of color coding here. So GCF, I did purple, and I'll make that purple here. LCM, I did green, so I'm gonna make that green here. Now you don't have to use the same colors that I do, but I do want you to color code them so that they match. Okay, so now let's do this. Let's look at number 1 for our examples. Least common multiple of 6 and 8. So how you find this is you list out the multiples of 6. So you say 6 is, well, there's 6, and then 12. So I'm just adding 6 each time. It's another multiple of 6. So this is like 6 times 1, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Right, I can keep going. 36, I could keep going. And you want to do the same thing for 8. So 8 would be 8, and then 8 plus 8, or 8 times 2 would be 16, and then 24, and then 32, and you can keep going, but we want to stop because they have a number that's in common now, right? The common multiple, their smallest one, is 24. Okay, so it's important to note that when you look at the least common multiple, it's never going to be smaller than either of these numbers, right? Because these just keep getting bigger. Okay, and it could be equal to that number, like these can both be 8s or both be 6s, but it's not going to be smaller than 6 or 8. It's going to be bigger. Okay, so in this case, they both have 24 in common. Okay, so we're going to write that. They both have 24 in common. So the LCM is 24. And now let's do the greatest common factor. So greatest common factor of 2 and 8 is when you take two numbers and you break them down into numbers that when you multiply them together, you get 2 or you get 8, and we do those separately. So like 2, we can break that down into 2 times 1. And there's no really other way to break that down. So 2, the greatest common factors are 2 and 1. And we'll do the same thing for 8. So 8, if I break that down, I can get 8 and 1, right? 8 times 1. This could be 4 times 2. And this could be 2 times 2. So the greatest common factors for 8 are, let's see all the numbers that I have here. I've got a 1, I've got a 2, I've got a 4, and I've got an 8. So there are 4 numbers there that go in 8. And so when you're looking for the greatest common factor, the greatest one they have in common is going to be 2. So they both have 2 in common. So the GCF is equal to 2. So in this one, you're looking for the greatest number. In this one, you're looking for the smallest number. But in both instances, you're listing out the numbers. At this point, you're going to follow directions to do these problems on the left side. So we've got some problems here that have GCF and LCM. And it says, on a rating of 1 through 5, how comfortable are you with this concept? 5 is the highest. So I want you to mark this so your teacher knows how comfortable you are with this. And for these problems, you're going to do the same thing I did in these two examples, is find the greatest common factor between these two numbers, and then the least common multiple between the two numbers, okay? And the ones they have in common go in the middle. So this is like a Venn diagram. Okay, so that's what you're going to work on. And then show your teacher when you're done so that they can review it and know that you're ready to move on. So sticking with our operations with rational numbers, we're going to get into adding and subtracting fractions. So you have these two pieces of paper that you're going to cut out just like you cut out the other two, and also an activity that's going to go on the following page. Okay, but you don't have to worry about cutting this out yet. For now, just cut out these two, and you can either tape them in after we take the notes, or you can put them in first and take the notes after. The only thing is, if you put them in first and you use glue, sometimes the glue gets wet, so it gets hard to write over that. So you just got to be wary about that. But go ahead and pause the video and you can cut out and put those in your book, or choose to do the notes after. All right, so let's take a look at adding and subtracting with fractions. Again, we're going to start with another I can statement. So this one's going to be pretty straightforward. I can add and subtract fractions. Here's the key though, with like and unlike, denominators. Okay, now before we get into actually adding and subtracting the fractions, we want to talk about the two different types of numbers you'll be seeing. We have two different types of fractions we work with. One is called a mixed number. So a mixed number consists of, and I'll do this in a different color, I'll do this in green. So it consists of an integer and a proper fraction. So a proper fraction is just when the numerator is smaller than the denominator, like 2 is smaller than 3, so this is 2/3. So this would be in a mixed number, 4 and 2/3, your 4 whole numbers, right, and 2 of 3 parts. Okay, so now conversely, what is an improper fraction? So an improper fraction occurs when the numerator is greater than the denominator. Okay, and I'll do that one in purple. So when the numerator is greater than the denominator, okay. Now there are ways to add fractions that are both mixed numbers and fractions that are mixed numbers and improper, and kind of mixing the two together. But really the best way to add fractions is if we get them either both into a mixed number, okay, with the same denominator, or both into an improper fraction with the same denominator. That's how we can add them together, okay? And it's usually easier to make them both improper. So let's kind of work with that. Let's go with the first one here. Let's make this mixed number, 4 and 2/3, into an improper fraction. So the way you do that is the 3 here is the denominator. So if you think about a fraction as part over a whole, this is 3, this is how you make a whole. It takes 3 parts, right? If this was 3/3, we'd have another whole, and that would change that to 5. So we have 4 wholes, okay? So full wholes mean that we have 4 3s. So you're gonna take 4 and you multiply it by 3, and then you add the 2 parts you have left over. So this becomes 4 times 3 plus 2, which is then 4 times 3 is 12, plus 2 is 14. So 14 over 3. So you're multiplying the integer by the denominator and then adding it to the numerator. Okay, so that's really what you have to remember here. Now to go the other way, you're trying to see how many, right, you have more parts than you do a whole. If I broke this up into eighths, right, I'd have 8 eighths would make 1, and then I'd have 4 left over. So how many times, this is what I usually ask my students, how many times can 8 go into 12? Well, it can go in 1 time. So it goes in once. And there's my integer. And then you say, well, how much is left over? Because it went in once. Right? So if I take 8 away from 12, I have 4 left. So that's 1 and 4 eighths. And what we want to do now is we want to simplify that, right? Because you can reduce 4 over 8. 4 over 8, they both have a common factor of 2. Right? 2 goes into both of those. So if I divide both of those by 2, I still have my 1 whole, and this becomes 2 fourths. And if you noticed before I did, that they actually have a common factor of 2, but their greatest common factor was 4. So if I had started this with a 4, it would be all the way simplified, because I could keep going with 2 fourths. Right, so if I divide both of those by 4, then we'd have 1 whole, and 4 divided by 4 is 1. 8 divided by 4 is 2. So you may have been able to notice right away that 1 and 4 eighths is the same as 1 and 1/2, because 4 is half of 8. But that's kind of how you see the two numbers. So as we keep going down, it's important to note that in order to add or subtract fractions, we need to have a common denominator. Okay, the adding and the subtracting, you know how to do that already. So I don't have to break this up into adding fractions and then subtracting fractions, because the process is the same. Only one you're adding and the other you're subtracting. But making those denominators common, that's really the process that you have to learn, and that process that you have to get used to. So let's bring it down to these 2 examples here. The one on the left, these already have like denominators. They're already common denominator, right? They're both in eighths. So it's easy to add these together. For example, let's make a whole, and I'll show you with a model. And let's divide it into eighths. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And so we have 5 eighths, so that's 5 of them. Right? And we're adding 1/8. That represents 1/8. So how many eighths do we have altogether? Well, we have 5 and 1, which is 6. So the total answer here is that they both have the denominator 8, and 5 plus 1 is 6. Now we can reduce 6 over 8. What number goes into both 6 and 8, right? What's a common factor between them? 1 goes in, but that doesn't really help us. 2 goes in. So let's see, does 3 go into both? No. 4 doesn't go into both. 5 doesn't. 6 doesn't. And at that point, I'm above 6. So there's no point in trying any other numbers. So I know that 2 goes into both. So to reduce it, I'm going to divide both the top and the bottom by 2. And that's going to give me my final answer. So 6 over 8 is the same as 3 over 4. And that's my answer. So that's with like denominators. It's a little bit more tricky when you have unlike denominators, and that's the problem we're about to do next. All right, there's a trick for adding and subtracting with fractions that have unlike denominators. One way, and the more classical way to do it, is to take the 6 and the 4 and you figure out what their least common multiple is, right? And you look at the 6 and pretend this is a 4, and you look at which one has least in common, and that's going to be the fraction that you're going to use. That's going to be your new denominator. And then you change both of those fractions to have that denominator. What I'm going to do in this video is show you a trick. And it's a trick that your book shows you with a more algebraic definition. I'm going to show you how it's used in practice. Okay, so for this, you're actually going to need 3 different colors. So I'm going to use, so the colors that I'm going to use are blue, green, and red. Okay, so what I want to do here for my trick is I'm going to take the 5 and I'm going to multiply it by 4. And you get 5 times 4. I'm going to write that off to the side here. Then, with a different color now, you're going to take the 6 and you're going to multiply it by 1. So you have 6 times 1. And you're going to put that off to the side here. Now, this is addition. So we're going to add these 2 numbers together. And when you do that, you get, well, 5 times 4 is 20. Six times 1 is 6. So when you add both those together, you get 26. Okay. Now the denominator is why we multiplied across, okay? Because the denominator is going to be 6 times 4, which is 24. Okay, some people call this the butterfly method. So my fraction now is 26 over 24. And let's see if we can reduce that. What number goes into both 26 and 24? They're pretty large, but I know they're both even numbers. That means 2 can go into them. So I'm going to divide both of the numbers by 2. And when I do that, I get 13 over 12. And of course, that is an improper fraction, right? Because the definition, again, of an improper fraction is when the numerator is larger than the denominator. So I have 13/12, which really means that I have 12 goes into 13 once, and I have 1 left over. So 1 and 1/12. So we got 1 and 1/12 for that one, and then 3/4 for this one. Okay, so that's how you add and subtract with fractions. On the left side, you're going to use the same process with this paper that says your turn. You're going to circle 1 through 5, 5 being the highest on how comfortable you are with adding and subtracting fractions. And you're going to attempt these problems and show your teacher when you're done to see if you understand the material enough to go to the practice problems. So continuing with operations with rational numbers, I want you to try out this activity. This is on identifying equal fractions. So in this gumball here, you have fractions that are equal to 3/4. And in this gumball machine here, you have fractions that are equal to 1/4. And you have all these little gumballs here on this page that you're going to either cut out, or if you wanted to, you could just kind of make a circle here and color them in so you don't have to go through that whole process. But you're going to put the gumballs into the machines and then answer these questions. This is going to go on the left side, so you're going to cut this out, and this is going to go on the left side. And this, obviously, you're not going to put that over here. We're going to use this page for notes for the next video. This is going to be just kind of like more practice on equal fractions. So you're going to take these little gumballs like 27/36, and you're going to place them into which one they belong into by either gluing them or just drawing a circle and writing in the fraction. That's up to you. This next video, continuing with operations with rational numbers, is multiplying with fractions. So we've got some models that we're going to do to show how multiplying with fractions works. And we're going to use some color with that, as well as some notes and some practice problems. And then next we'll go over dividing. So for now, what you want to do is take these, and you're just going to cut this out. Okay, and you don't need both of them, you just need one of them. For this one, you have 6 coordinate planes or grids, and you're going to cut out all 6 of these individually. So you can pause the video and go ahead and start that. And when you're finished cutting everything out, we're only going to use 4 of those grid planes. And you're going to take this, you have this diamond, you're going to fold it back, okay? You can put glue on the back side here, and you're going to tape it down so it's kind of in the middle. And we're going to do some multiplying fraction problems over here. I'm going to do these 2, and then you're going to do those 2 on your own. So I'm going to zoom in here a little bit so you can see it. Here's how we multiply fractions. So when we have proper fractions, okay, we multiply the numerator, and then we multiply the denominator, and then we simplify. So for example, if you had like 3/8 times 1/5, you multiply the numerators. 3 times 1 is 3. And then you multiply the denominators. 8 times 5 is 40. And then you would simplify if you can. So since there's no number that's, or no factor that's in common between 3 and 40, we can't reduce it, so we would leave it as 3/40. So that would be our final answer. Now for this one, if you have mixed numbers, okay, you first want to convert it to an improper fraction. So 2 2/3 would become 8/3, because 2 times 3 is 6, plus 2 is 8, so you get 8/3. 3 1/4, again, you want to convert to an improper fraction. So you'd get 3 times 4 is 12 plus 1, so 13/4. And then you multiply just as you would with proper fractions. So 8 times 13 is 104. 3 times 4 is 12. And so we can convert that to a mixed number by first reducing. So 4 goes into both 104 and 12. And that gives us 26/3. I'm sorry if it's hard to see there. And then we can make that into a mixed number. So how many times does 3 go into 26? It goes in 8 times, and there are 2 left over. So 8 2/3. So we're going to do these 2 problems as a model up here at the top. We're going to do 1/2 times 3/4. So as a model, what we can do is we can take 1/2 of this grid and we can shade in one of them, right? So we're going to cut it into 2, and we're going to shade one of them. So let's shade the left part. And you don't have to actually count out the grid marks, especially when you have like 9ths or 11ths. Like there are only 10 squares here, so yes, I did 1/2 of 10, which was 5, and did 5 squares, but you don't necessarily have to do that every time. In fact, it's going to be hard to do 9ths when you have 10 squares. But let's keep going now. So we're multiplying that by 3/4. So what I'm going to do is I'm going to go now the other direction. So where before I did 1/2 and I went up or down, okay, now I'm going to shade the other way with 3/4. So I want to split this into fourths. So halves and then half of a half. And just 3 of them are going to be colored in. 1, 2, 3. So let's see what we get for an answer here. We did 1/2, right, times 3/4. Now we know from our steps here we should get 3/8. So let's see how many parts we broke this whole down into. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8/8, right? Now how many are crossed? Like how many are in common shaded in? It's just these 3. So the answer for this one is going to be 3/8. Okay, each of these represents an 1/8. And we're going to do the same thing over here. We're going to do 3/5. So I'm going to divide this into fifths. And I'm going to shade in 3 of them. So 1, 2, 3. And I'm multiplying that by 1/2. And that shading goes the other direction. So let's see, how many parts did I break this whole up into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I broke that up into 10s. And how many cross shades did I have, or how many did I have in common? So it's 1, 2, 3 were shaded for both. So that should be 3/10. And what you're going to do is the same thing, but your problems are going to be 4/11 times 2/5 and 2/9 times 5/7. So you're going to do those 2 problems using the model, okay? And when you're done with that, show your teacher and you'll be ready to move on with division. So when we're dividing fractions, here's how I want you to start out your notes. I don't really have handouts for this one, okay? So it's just going to be kind of straight up note taking. So to divide fractions, we actually use what's called the reciprocal. And the reciprocal helps us to divide fractions because it allows us to change from division to multiplication. Here's why. So here's what I want you to write down in your notes. A reciprocal is the value needed to have a product of 1. You find this by flipping the numerator and denominator. So for example, 2 times what number would be 1? Well, to figure out what this number would be, you rewrite 2 as a fraction, so 2/1, and then you flip it. So of course you may have already known this, but 2 times 1/2 equals 1, okay? So you can do it really quick, like 2 times 1/2 is 1, and not think about flipping numerator and denominator or having to change something into a fraction. But if you have something like 165 78ths, and you want to figure out what number times that would give you 1, all you have to do is flip the 165 and the 78, and that would give you the reciprocal. So let me show you the steps on dividing with the fractions. So first, we're going to keep the first fraction, so that one stays as it is. So our first example here is with proper fractions. We have 3/5 divided by 2/7. So this one stays as 3/5. And then we change it to multiplication. And we're now going to multiply by the reciprocal, which means we take 2/7 and we flip it to 7/2. That's a bad looking 7. And now we're going to multiply. That's 3 times 7 gives you 21 over 5 times 2, which is 10. And then you can make that into a mixed number. So how many times does 10 go into 21? And so it goes in 10, 20, not 30. So it goes in twice with 1 of the 10 left over. So that's 2 1/10. Now, dividing mixed numbers is just as easy. We first just have to convert them to improper fractions. So 2 3/4, that becomes 2 times 4 is 8, plus 3 is 11. So that becomes 11/4 divided by 1 2/8. So 1 times 8 is 8, plus 2 is 10. So divided by 10/8. And then now we can do the keep, change, and the reciprocal. So we keep 11/4. We change it to multiplication. And we flip the second number. So this becomes 8/10. Right? And now I can multiply straight across. 11 times 8 is 88. 4 times 10 is 40. So that's 88/40. Now, let's change that to a mixed number. So 40 goes into 88. Let's see, 40, and then 80, and then it would be 120, so it only goes in twice. And then that's 80, so we'd have 8 left. And I can further reduce this. So 2 4/8. What goes into both 4 and 8? Well, we kind of did this earlier, 4. So my final answer is going to be 2 1/2. So that's how you divide with fractions. Now on the left side, I'm going to give you some problems to do on your own. So you're going to be 4 multiplication and 4 division. So on the left side of your book, you're going to do the following 8 problems. You're going to evaluate 3/4 times 2/8 and -4/7 times 6/8. So remember your negative and your multiplication rules. 1 2/3 times 5. 2 3/8 times -1 1/3. 7/8 divided by 1/8. -3 divided by 1/4. 4 3/4 divided by 1 1/4. And the last one is 2 3/7 divided by -1 1/7. When you're done with that one, show your teacher your answers so you can prove that you're ready to move on to the next step.